Good evening. Today in physics class we are going to discuss about the gas law. The elementary law of the gases, that is the Boyle's law. The scientist Boyle's born in 1627. He have discovered himself with the help of test tubes that at the atmospheric pressure the level of the two arms were equal. That means what? At constant temperature the product of pressure and volume is always constant. How we have to observe? When we drop few more of mercury in one of that tube, it will found in the same. The air side have increased, the pressure have increased, volume decreased. Volume of the black color have decreased. That volume of the black color have decreased from here to here. Pressure increased, but both constant is same because as constant temperature. The product of the pressure and volume is the same. After taking the all data of this, it is resultantly that the curve will come of the pressure volume graph will look like this, because this is pressure into volume equal to constant. At constant temperature, condition is what? At constant temperature. That is the Boyle's law. Know that the fast compression heat of the gas measuring the volume at the higher pressure. He waited for the cool back and repeated the experiment at different added pressure. It is found the product of the pressure and volume is always keeping constant. Later on, it's come into mind, okay, at constant temperature the product of the pressure and volume is constant. And what is really happening when the temperature is changing? What is the relation between the pressure and volume and temperature at different temperature conditions? That Mr. Charles have arrived. After Boyle's, a century after Boyle's, after hundred of years, Mr. Charles discovered at constant pressure. Since you know, we are at that time taking the two variables. Here the three variables: pressure, volume and temperature. So to comparison the temperature either with respect to the volume or either with respect to the pressure, we should have to keep either one of the P or V, the pressure or volume, as constant. Then after century of year, Mr. Charles, scientist Charles, experimented on keeping the pressure constant and measured the volume with respect to change of the temperature. He found it is linear. volume increases linear with increase in temperature, and he have concluded that volume is directly proportional to temperature at constant pressure. And what is the proportionality? That volume at 0 degree plus the temperature scale in Kelvin, that we can say 1 degree centigrade at 273 Kelvin. Suppose you know the Kelvin scale. So at minus 270 degrees centigrade, the Kelvin temperature scale is like that. This. Then V is directly proportional to T in Kelvin scale at absolute temperature. Then remaining, what is the relation between pressure? Then it is same. P is directly proportional to T. But the constant of proportionality is here arrived, that is N and R. R is the universal gas constant. R is what? Universal gas constant. R here. And what is N? N is the moles of the gas, as we know, that is 8.314 joules per mole per Kelvin. So I told you at constant volume P is directly proportional to T, and that P is directly proportional to T and V is directly proportional to T. Then what is the constant is there? Nr is the constant, where N is the mole of the gas and R is the universal constant, where R value is what? 8.314 joules per mole per Kelvin, where temperature is in absolute scale, Kelvin scale. So you understood the combination of the Boyle's law and Joule's law. What Boyle's law define? PV card. Boyle's law define the PV card, that is pressure is directly proportional to volume at constant temperature. And the Charles define the temperature, keeping the either P or V constant, the relation between pressure and volume. In either case, at keeping constant one of the element, that P or V, he found is directly proportional. So it's arrived PV equal to nRT, where T is the in Kelvin scale, temperature Kelvin scale, N is the moles and R is the gas universal constant. So in particular gas, then PV by T is always constant, that is equal to nR. So particular any gas in one state, initial state, suppose its pressure is P1, volume is V1 and temperature is T1, and after passage of time, increase of temperature, it's become the P2 the pressure, V2 the volume, and T2 the temperature. Then both the ratio, because PV by T equal to constant, that is NR. Then at the both state, increasing the temperature T1 to T2, resultantly the P1 V1 have increased from P1 V1 to P2 V2. That parts become equal. Understood? Because this equal to constant and this equal to constant, that is a universal constant, so both are equating equal, and with this application of formula we can calculate any problem. After the classes we will go to online for the mock test of this chapter. Since you are learning here in a regular coaching class, your online mock test is free. That is given to you for your self-assessment, for your bringing up your confidence of study. That it was having any parameter of between this P1 V1 T1 and P2 V2 T2 that is unknown, and other 5 parameter is known to you, then you can calculate that unknown parameter with this formula, keeping in mind the temperature should be converted into absolute temperature. But in this particular case, since both sides is T1 and T2, so any case that T1 T2 is changing here in question, so you have to convert it T1 T2 with the absolute temperature, and the pressure will finally come in atmospheric pressure. Okay, the pressure is what? The unit pressure is what? Atmospheric. The volume is what? Liter. Okay. So we got